Good morning, learners, and welcome to my series here on electrochemistry. And in my lesson 1, at the end of this lesson, you need to be able to define the electrochemistry. I'll also be getting back to a Form 2 topic that we looked at, that is the effect of electric current on substances. Now, I will start by defining, and before I talk about definition, maybe I must say here that there's a big relationship between this topic here on electrolysis, or the effect of electric current on substances, and electrochemistry. Now, the electrochemistry here may be defined as electrochemistry is a branch of chemistry that deals with the relationship between electrical energy and chemical reactions Now, having said this one here now, you can actually now be able to tell why it is important to review the effect of electric current on substances. Now, let us get back to what we learned in our Form 2. Now, in our Form 2 here, we did mention here that when an electric current is passed through some substances, some reactions occurs. Now, but though it may be in others, you are going to realize that no reaction occurs, or basically maybe that some substances will not even allow an electric current to pass through them. And this, we call them non-conductors, or at times we call them insulators. However, we mentioned here that there are some substances that will allow electric current to pass through them. And these are conductors. Now, things like metals. Metals are good conductors of electricity here. Now, but one important thing that we mentioned here about the whole thing here is that the ionic compounds in molten state and in aqueous state are going to conduct an electric current. They are going to conduct an electric current. Now, with a simple reason that they do have the mobile ions. They have the mobile ions. Remember, for conductors or the metal conductors, they use delocalized electrons. Now, those ones we say that they have the mobile ions, and therefore an electric current here can be able to pass through them, or they're able to conduct electric current using the mobile ions. Now, as it does this, some chemical reactions we said occurs. Some chemical reactions occurs here, and an electrolyte here is actually decomposed. Now, let's have a review of it. We're going to review this here. I'm going to have basically I'm going to have here an electrolytic cell. I want us to have that one there, and I want to think about an electrolyte here that we mentioned here, like lead 2 bromide, and this one should be molten. Now, very first we look at this. We said here that we need to have our battery here, which is actually meant to provide the electric current. It is meant to provide an electric current. Now, of course, here the simple basics of physics here. This side here with a long line here, we represented as a positive terminal, and this one is negative. That one is actually negative. Now, then of course we have a switch. There's just a simple circuit. You may have a switch there, and there you are. Now, this particular here, through this, these are copper wires, by the way. These are copper wires. These are copper wires, and then we are going to have these two conductors here. Now, these conductors here, they are supposed to be inert. They are supposed to be inert here, and therefore we may use something like graphite. Look at that. We may use something like graphite. We may use something like graphite. Now, when this switch is closed, when the switch is closed, here, the electromotive force, now this one is a battery here. When the switch is closed, what will happen here is that we're going to have an electromotive force here that will push. An electromotive force is here will push electrons in this direction. Now, we must have mentioned in Form 2 that towards the side here, and the positive being electron deficient, in other words, it has fewer electrons, it has less electrons than protons. What will happen here is that it is going to take up those electrons. So this positive here is we will be taking up the electrons, while the electrons will be releasing them. Basically, that is what we talked about. Now, one other thing here, when this one is negative, it makes this electrode negatively charged. It makes this electrode negatively charged. Now, and I think this one here, not I think, but we call it a cathode. This is the electrode connected to the negative terminal of the battery. At the same time, the electrode connected to the positive terminal of the battery, we call it anode. We call it anode. Now, let me discuss here. Let me discuss the reactions that actually happens at the electrodes. Let me discuss the reaction that happens at the electrodes. I'm going to start here with the cathode. I'm going to start with the cathode here. And let's see what really happens at the cathode. Now, I've just mentioned about cathode here. One, it is negatively charged because it is connected to the negative terminal of the battery. Number two, this cathode has excess of electrons that are coming out or coming from the negative terminal of the battery. Now, so what happens here, the cathode being negatively charged here, it attracts the positively charged ions here, and the positively charged ions, we call them cations. We call them cations. Now, once the cations get to the cathode, what will happen to them? Look at that. What will happen to them here? Now, the cations here, the cations gain electrons. The cations gain electrons to form metal atoms. Look at that. To form metal atoms. Remember, the cations are positively charged. I want you to get that. They are positively charged. That means they have some deficiency of electrons. They have some deficiency of electrons. Now, in this particular case here, I want us to think about this. We have lead, molten lead to bromide. Now, lead to bromide, when in molten state, then the ionic bond is broken. And now we're going to have the free lead ions and we have bromide ions. Therefore, we're going to have lead ions. And lead ions here, the fact that it is too positive means, that it has already lost 2 electrons. And when it comes here now, it is going to gain the 2 electrons that it earlier lost. And we're going to have the lead metal. You're going to have the lead metal. That's what we're talking about. Now, therefore, in this particular case, we can also be able to mention about the observation that will be made here. The observation made at the cathode. The observation made at the cathode will obviously be a gray. A solid is deposited. Look at that. a gray solid is deposited. Why? Because these lead atoms here, the lead atoms formed here are gray. The lead atoms formed here are gray. That's why we are going to observe that. Now, let me mention about the anode again here. Now, anode, as we can see, anode is actually connected to the positive terminal of the battery, and therefore it is positively charged. And being positively charged, it is going to attract the negatively charged ions. Therefore, it is actually going to attract the negatively charged ions, and we call them anions. In our case here, these are the bromide ions. For cations, of course, we had the lead ions. Now, so anode here attracts the bromide ions. Now, when the bromide ions get here, when they get to the anode, they are going to lose electrons. Keep following here. I mentioned here, when you see a negatively charged ion, it means that it has an excess electron. Like this particular one here means that this bromide ion here, if you try to compare the bromide ion with the bromine atom, this one has an excess of 1 electron. It has an excess of 1 electron. Now, what happens here? It is going to lose that excess electron here. So we can mention here, anions lose electrons at the anode. The anions lose electrons. They are going to lose electrons there, forming non-metal atoms. Look at that. Non-metal atoms. They're going to form non-metal atoms. That's what we're talking about. In this particular case here, we've got to mention about a bromide ion, for instance here. A bromide ion loses electrons. I want us to look at this one again here. Instead of using minus an electron, what we basically do here, I'm going to have an arrow, and then I'm going to present the electron on the right side with a plus. So what I'm going to have here is this bromine here forming a bromine atom, look at that, with no charge, and then plus an electron. That's what I'm talking about. Now that means here, if I'm going to have 2 bromide ions, they are going to form 2 bromine atoms. Now the 2 bromine atoms here will combine and form a bromine molecule, and the 2 electrons will be released. And having said that, of course, what does that mean? What will be observation? Now, the observation here, what we are going to observe in this particular electrolytic cell here is the formation of this brown gas. Now, the formation is not an observation. The observation is what we actually see. So what are we going to see here? We say here a red-brown gas. Look at that, a red-brown gas produced. Red-brown gas produced, or red-brown bubbles will be produced. Remember, we can also be able to view them. Why do we require this heat as this process goes on? Number one here, of course, it is to maintain, it is actually to maintain my lead-2 bromide here in the molten state. Why? Because if this lead-2 bromide here solidifies, if it happens to solidify, then what we are going to have on solidifying here is that the ions will be brought back together, and they will be joined by the ionic bonds, and therefore they will not move. And if they're not going to move, then what we are going to have here is that the circuit now will not be complete, and therefore no reactions will be expected at the electrodes. Now finally here, let me just mention a few terms that we used, or the definition of some terms that we used in this electrolysis. This one is just preparing us here to even a more advanced or basically maybe we'll be discussing more on this electrolysis. We'll be talking about some electrolytes here having more than 2 ions. More than 2 ions. We'll be discussing this here. For example, the aqueous, ionic substances, and so on and so forth. So maybe now a quick summary of our lesson today. That when an electric current is passed through molten or aqueous ionic compounds, reactions occurs at the electrodes. Then number 2, we have the definition of electrolytes. What are electrolytes here? Now, electrolytes are simply substances that allows the electric current to pass through them and are decomposed. In other words, substances that are decomposed when electric current is passed through them. Then point number 3, electrolysis is simply the decomposition of an electrolyte using electric current. Now point number 4, definition of electrodes. Electrodes are solid conductors through which electric current enters and leaves the electrolytes. Now, the inert electrodes will be used in this particular case here. We have graphite and platinum. The implication of using reactive electrodes is a reaction may be happening, or those electrodes may be losing electrons at the anode because they have a higher tendency of losing electrons. We are going to view this in our further discussion on electrolysis. Then point number 6, point number 5, at the anode, very important here. At the anode, anions lose electrons. And when you're writing the half equations at the anode, we mentioned here, instead of talking about minus, for example, a non-metal like bromide, not minus an electron, no. Put the minus, put the electron on the right side, put it on the right side, and so that you're going to have a plus. I think we can identify what we just mentioned there. So at the anode, anions lose electrons, and they are going to form the non-metal atoms. Now, the observation that we're going to make here depends on the color of the non-metal that will be formed. In our case there, we were using bromine. Bromine gas was formed. Now, bromine gas is normally red-brown, and therefore we're going to have a red-brown gas forming at the anode. And then at the cathode, of course, the cations there will be attracted because cathode is negatively charged, and they're going to gain electrons forming metal atoms. They're going to form metal atoms, and actually the gain of electrons, we will be looking at this here, will be called reduction. It is important we know that right away. Then the loss of electrons, we'll be calling it oxidation. I'm also going to look at that maybe in our second or third lesson. Then finally, we have binary electrolytes contains 1 cation and 1 anion. Contains 1 cation and 1 anion. That is what we are talking about. Now, so in my next lesson, I'll be taking you through the redox reactions. So that we are able to see how electrons actually are gained and lost in a redox reaction. We shall also be looking at the rules that we use in assigning oxidation numbers, and we'll be able to move forward from there. Otherwise, thank you very much. Kindly ensure that you subscribe to my channel to be able to get the updates of lesson 2, 3, 4 moving forward, and all will be well. Thank you and God bless.